My name is Ted Burnell. I'm a Senior Solution Architect at Red Hat, and I'm hosting this afternoon's panel called, um, that's not our slide. So ignore that slide, okay? But we are conducting a panel today. I want to get started so we have enough time to have a decent panel. But it's called Managing OpenStack and Infrastructure as a Service Clouds. So hopefully that's the session everybody thinks that this is. And to introduce the panel speakers really quick, we have Chris Wells, who's works for product marketing at Red Hat. He works on the product team that's going to handle both Satellite 6 and CloudForms. Barry Sheward from Lockheed Martin, Mark Poole from Army ECBIZ, and we have Christopher Dale from Colloquium Incorporated. And today's talk, what we're going to talk about is both the challenges and the way forward as far as managing infrastructure as a service and OpenStack clouds, whether it be VMware, Red Hat Enterprise Virtualization, of course, OpenStack. Some of the challenges that these gentlemen have faced throughout their time working their different environments. And Chris is going to chime in occasionally and tell us how Red Hat's addressing some of the issues that these guys are bringing up. Okay, so you guys are going to get an opportunity to learn not just what we've done in the past as Red Hat to provide good management tools for you guys to manage your servers and your virtual servers, but you're also going to learn how we're moving forward with cloud computing and the management of your cloud infrastructure. So without, also if you guys look in your programs, there should be a gentleman here named Ron Ross. He is sick today with the flu, so he couldn't join us. But to start things off, I'd like to start with Chris, and we'll just work our way down. If you guys could just spend a minute and a half telling us who you are, what you do, and what kind of infrastructure you're currently working with. I think that'd be a good start.
Okay, very good. Well, as Ted said, my name is Chris Wells. I work at Red Hat. I've been there for a little over 5 years. I work inside of our cloud business unit. The way that we're structured inside of Red Hat is in terms of how we manage our products and our roadmaps and our technologies and our go-to-market. We have the different business units. We have one around the platform team, which primarily focuses on RHEL, middleware team that focuses on our JBoss products. We have storage. We have our virtualization team, which focuses on both Vert and OpenStack, kind of at the infrastructure layer. And the cloud business unit really focuses on the management layer of things. We have 3 primary products. One is our OpenShift product, which is platform as a service. And then the team that I manage has responsibility for 2 of our management products. One is Red Hat Satellite, which some of you probably use, which is our traditional lifecycle management for managing Red Hat Enterprise Linux. And then also a newer one of the product portfolio is CloudForms, which is our cloud management platform.
Called Colloquium. Most of my time is spent with clients advocating the use of open source components within their spaces. There's also an education component in there, helping them understand how to properly leverage open source within their infrastructures. And then I spend probably a lion's share of my time using a lot of what will soon be legacy components in the open source space to manage large scale infrastructures. And that's a lot of satellite work. We've done some REV work, and we're looking forward in getting involved with both OpenStack and also CloudForms.
All right, thanks, guys. One of the challenges that we hear from a lot of our customers is that their current management tools just aren't satisfying their needs for virtualized infrastructures, where the resource usage may be a little bit of a roller coaster, where it goes up and down, different numbers of VMs online from day to day. And then, with cloud computing, it's going to be even worse, right? Because then you're talking about multi-tenancy, and now you're going to have multiple people doing the same kind of workloads, where there's different numbers of machines going online, offline, from day to day. Is that something that any of you guys have experienced on the panel that you could share with us, how you're managing that infrastructure, where the usage changes from day to day? And maybe tell us what tools you're using to keep the systems patched and keep them compliant with information assurance policies at your particular areas.
So I'll give this a stab from the more of the legacy perspective. So I'm sure most of you are familiar with the products as they've existed over the last several years. And what tends to happen in large deployments, particularly ones that fluctuate, is you build to your peak and you leave it running. And you do it for a couple key reasons. One is security. How do I keep things patched if they're offline or if they're constantly online, offline, auto-scaling? And to the point of some of the need for change as we move forward into a more cloud-centric environment is to be able to cope with some of those problems. So if you are in the current model, you just have to keep things online to be compliant with a host of government regulations for security, among other things. So there's probably a couple things that need to change. One, we need the technology, but then we also need to have policy within client spaces be able to take advantage of some of those changes.
All right, thanks, Christopher. Barry or Mark? The other one of you? Barry, go ahead. I can go first. You want?
So I think typically people tend to look at enterprise management and cloud management as two separate disciplines. What we've done is take a holistic view and integrate the cloud with the enterprise management so that, for example, if a machine goes down, we can determine, well, did the user go in through the cloud interface and actually shut that machine down, or was it shut down by some other mechanism? And that's how we're kind of providing availability data to our users. They get basically a root cause analysis of why that machine isn't running.
So what we've been looking at is, so we use some integrated services in order to check the availability of not just the hardware itself and whether or not the servers are up and down, but looking at the services itself and the capabilities that we provide. We've looked at Nagios, and we actually are employing that now to set some various bells and service level pings on that as to whether or not when something goes up and down. As far as the management for security, we rely on the battle stack in order to push out, and of course the government's HPSSS program to look for the, the various vulnerabilities or shortcomings of our systems that I mentioned then.
And that's something that we're also looking at with Satellite 6. We started with Satellite 5, where we integrated the SCAP scanning ability. Chris, can you touch on that a little bit, what we're doing with Satellite 6 and whether we're going to continue down the security path there?
Well, yeah, absolutely. I mean, when you take a look at the Satellite product line and where it's been, so if you're not familiar with Satellite, it's the tool that we use at Red Hat to manage the lifecycle of Red Hat Enterprise Linux systems, so everything from the initial provisioning of systems, ongoing patch management, configuration management, the management of the content and of those core systems. And if you take a look at where Satellite's come from, you know, it's been a product that has been very successful for us, but we've had it around for about 10 years. And if you think, you know, go back in time a decade ago, if you think of how it was designed and the problems it was trying to solve, I mean, 10 years ago, if we were having this discussion, if we would have mentioned clouds, it would have been about the weather outside. It definitely would not have been about what's going on in the data center, let alone things like virtualization. And so Satellite was really designed to manage physical systems, and that's how the entire architecture was put together. And then over time, we adapted it to manage virtualized systems. But I'm sure those of you that are Satellite customers today probably realize that when you go in and manage a virtual system, it's really like managing a physical system, because we just adapted Satellite to be able to do that. I see some heads nodding in the audience. So one of the things that we're doing, and we're very excited about, is that next year we will bring out a new version of Satellite, Satellite 6, to the market. And when you see it, it will look very different than what you're probably used to with Satellite 5. And one of the reasons it will be so different is we realize that we're taking all the kind of the goodness and of our experience and history that we've learned with Satellite 5 and all the things that you guys are talking about, what you want to do, that you want to have your system secured, you want to be able to patch them, you want to be able to keep them online and updated. We need to do all those things in a traditional environment, but we also need to adapt to the cloud environments, the heavily virtualized, hyperscale type of environments. So the product is fundamentally re-architected to take advantage of those kinds of things, to be able to do things like the multi-tenancy. I'm sure those of you that manage REL subscriptions today, you have that challenge of how do you handle the satellite certificate, how do you carve it up for different agencies or different programs that you're working on. It's very difficult to do in the Satellite 5 environment because of how it was architected, 10 years ago. We heard that from our customers, that we need to change those kinds of things, and you'll definitely see that things like subscription management, things like configuration management will be much more powerful and much more easier to use in a large-scale type of environment than they really are today in Satellite 5.
Great. Along with the resource or the configuration management comes resource management, especially in a cloud environment, right, where you can carve up your infrastructure and you can say, I want this user to have access to X number of resources or CPUs, RAM, disk space, whatever. How are you guys addressing that now in your current environments? Are any of you having to deal with that yet, or is that something that you're looking at having to deal with down the road? As far as how do you carve up your infrastructure for different users in the system, or even different tenants that are in the system? Is that
So a lot of what happens now, you view the cloud as this kind of black box. You build things, you push them out. You may have some heavy-hitting VMs. They may end up running on the same node. You may not know that. So there is some amount of work in the back end that has to take place with some rather laborious collection of information to figure out how to best distribute your workloads. In terms of scale, it tends to be, particularly if you're in a model where your users can create their own VMs, you walk in the morning, you have 12 more VMs that you're looking at having to deal with, and you don't know what's running on them. So that starts the process. Again, getting to the future tools, having better information up front. Once you have that information, you can act on it. But collecting it right now is pretty laborious.
Yeah, I'd like to jump on that one. So yeah, through most of our management of our infrastructure right now is just really done through the Rev Manager, which at this point really doesn't give us a whole lot of the metrics and collections that we need. So we rely on other party tools that we've integrated into the system. I think what we would need in the future is something that's going to tie that in, that's going to give us the metrics and utilization that goes along with right down to the infrastructure, the hardware, the VMs, and what resources are being capitalized amongst the hypervisors, and where they can better be spread across the infrastructure.
So our solution was designed from the beginning to be multi-tenant, and also within those tenant groups subdivided. So for example, we could provide production and test and development enclaves. We are able on a user by user basis to assign those to a particular set of those enclaves. And how we actually come across those enclaves is very much dependent on the cloud solution that we're working with. So, for example, one particular virtualization platform we work with, it breaks down to the underlying hardware and how that's set up. In other environments, it can break down to virtual data centers and other network-related features that those cloud providers have. So basically, once we build the integration, we can assign the user to the particular enclave that makes sense for their usage. And then typically we rely on the underlying virtualization technology to keep the resources allocated within those enclaves.
So in your environment, Barry, how do you handle patching of systems? Is every tenant in your environment responsible for their own patching and security, or is that handled at the macro level?
It's handled at the macro level. Basically, because we provide the templates that the tenants use, they automatically get the particular agents on those machines that handles all the patching.
Okay. Does anybody else have that where patching is handled by the infrastructure operator or the infrastructure managers, and not by yourselves or by the people who are spinning up the virtual machines? Is that something you guys see?
So in two of my largest environments that I work with, that's very much the case. You have people that are assigned pretty much full-time to doing the patching. And even with the tool, when you're talking 2,000, 4,000, 8,000 servers, even if I can say, hey, apply the patches to this group of 1,000, I still have a task that I have to follow up with, and that is, okay, all 1,000 patched. Are they working? And you may be immediately made aware because your monitoring tool says, hey, 3 nodes down, 5 nodes down, 10 nodes down. But then again, there's information collection that has to go on to try and narrow down what your particular problem is. But the ability to automate the core part of the patching is undoubtedly very valuable. It's what happens after that becomes the more time-consuming and problematic task.
But then you kind of run into the problem of, you have to provide the bodies, the expertise to keep everybody's systems patched. And if a patch goes wrong, and it doesn't install properly, then you're on the hook of the application going offline as well, right? So I think that kind of gets into the governance issue. What kind of tools are you guys using in your environments to meet governance requirements? As far as assigning rules such as, user X can only create a virtual machine that has 2 CPUs and 4 gigabytes of RAM, or he has limits on how many resources he can use. Not just quota, because a user could go in and create, if his quota is 20 CPUs, he could potentially go in and create a 20 CPU or a 64 gigabyte of RAM VM, especially with those ways that have exploded in the past where they can now use much more RAM and resources than before. How are you guys handling the governance issue of ensuring that users can't overutilize the resources that are in your environment?
What we've done in our environment is we have the capability of, we've got all the processes on how we go about establishing just your standard business processes of who's allowed to come in and say, hey, I need X, Y, and Z. But we've had the capability, we've developed almost like a self-provisioning portal where we've identified what an environment request would look like or what resources can be requested in a self-provisioning tool. So if one of the developers said, I need a dual core VM with 2 gigs of RAM and X amount of hard drive, the business rules manager would go in and say, go ahead and request it. The resources are available. It's a small virtual manager. Go ahead and spin that up. The other rules, if they said, well, I need 4 CPUs, 32 gigs of memory, and X, as the VMs start getting larger, the business process flow comes in and it starts to flag, say, okay, we've got your request. We know what you're going to use it for, but we won't self-provision this until it's been authorized by whoever that active entity would be to say whether or not they could use those tools or not.
Okay, and I know that's something that CloudForms can also do. So, you want to talk a little bit on that, Chris?
Oh, sure. So, one of the tools that we've brought out to, or one of our products, I should say, we've brought out to market in the last year is a tool called CloudForms, which is our cloud management platform. And it does really allow the operational management characteristics that you're talking about. So being able to not only set up a self-service portal, but putting all the policies in front of that of who's allowed to access it, how much they're allowed to consume. If you want to put like some workflow into it for like approvals, because in your case, I think that second example you said maybe it's a bigger system than what you would allow someone to automatically acquire. It needs to go to somebody else in a workflow for an approval and a manual, like an email or something to hit the approve button before it actually can be launched. Those are the types of things that CloudForms can do, along with other types of things around helping you determine capacity, utilization type of data, chargeback. I would say it's really a platform for going through and doing all the operational management type of characteristics that you need to do around a cloud. I think one of the things that's very interesting about the cloud environment and what's really changed kind of culturally, behaviorally with people over the last 5 years is this whole idea that the user, not the IT's operations person, but that end user, whether they be a developer or whoever, actually now has more power and is more to be able to acquire those resources via self-service. And there's now this kind of cultural pressure on the IT organization to have to be able to deliver against that demand. Whereas, 5 or 10 years ago, if you were in IT operations, you had the ability to say no. If someone said they wanted this particular box, they wanted it configured this way, and you didn't want to give it to them because you didn't have budget or policy or whatever, you really had the ability to say no. And I would say culturally in IT, that's really changed in the last 5 years. I mean, not just with IT equipment, but with like phones, the whole bring your own device and everything. There's just this huge culture change. And I think the challenge on the IT side is you don't just need systems management tools that allow you to go through and patch and secure your systems anymore. You really need operational management tools that allow you to provide that capability to your customer and kind of this cloud-like experience they want. But at the end of the day, especially here with government type of contracts, you still have to have control. You still have to be able to decide who actually gets permission. It's almost like you want to give the user the illusion that they're in control. But in reality, I see you nodding over there. The illusion that they're in control, but in reality, IT operations is still in control, but you're able to make it look like they're in control of it.
Just following up, one of the nice things in CloudForms is that sunset date, where particularly for environments where you have developers daily saying, I need. And in a conventional way, you go back and you look 3 months later and you find out that they've logged into the thing once but it's been running for 3 months. So in CloudForms, with those, particular type of users, you can say, okay, here's your resources. Oh, by the way, it turns off in 3 months. So you can, now there's nothing too magical about them calling back up and saying, hey, I'm really using it, extend it out another 3 months. So it's another administrative step, but you can keep your infrastructures clean of the monstrous amount of clutter that can accumulate in a user-driven environment.
So just to interject, we actually went a step further than that, because when we started to develop some of our integrations with the public cloud providers, the bills went on my credit card. And, and so we actually have the ability to say, I want this machine shut down at 5 p.m. and started back up at 9 a.m. the next day and off over the weekends. And that kind of level where if people really are developers, they're working 9 to 5, they don't need the VMs all the rest of the time.
Yeah, those are definitely things that you can do inside of CloudForms to be able to put the policies and stuff in place, because I think it's all, like I said, I think it's all about giving that user that illusion of control, but from the IT side, you still have full control of those systems.
Right, absolutely. We don't want to give, away too much control, though, as we move to a cloud environment. For instance, maybe managing who can use a public cloud and who can only use a private cloud. Are any of you gentlemen integrating with, both private and public clouds right now? Do you want to expand on that a little bit, Barry, and tell us, what kind of challenges you've had doing that?
Sure. So always there's the cost, right? The cost of developing or creating virtual machines in a private cloud is, for our user base, fairly insignificant compared to the costs of creating those virtual machines in a public cloud. Right? I've already mentioned before, we handle the multi-tenancy, and we have groups of machines carved up within the organizations. So on a particular user by user basis, we can say that this user has access to public cloud, for example, Amazon EC2 Cloud, or this particular user only has access to the 3 private clouds. They can create virtual machines. We have the ability as well on the enclave by enclave basis and user by user basis to define exactly what they can create in terms of number of CPU cores, the amount of memory. And we handle the translation because no cloud seems to treat these things the same, right? Your VMware deals in terms of memory and CPU, whereas your Amazon cloud deals in terms of instances, and OpenStack deals in terms of flavors. So having to manage all that is quite a complex job, but we've effectively normalized the whole process now.
Are you just using users, or are you also doing like any kind of role-based access control?
At the moment, two types of role: administrators that get access to everything, and underneath that, the actual users.
Mark, I know that you being in the military, that a lot of times in the military there's a high turnover rate because everybody moves on after X number of years, anywhere from 2 to 4 years. Is role-based access control something that you've had to look into? So people can sign in as a billet and not necessarily as a user to manage their instances?
Well, actually, we do our role-based access control based on the common access card. So what are so we use ELDF, SAML, and some other tools in there to go in, pull the credentials off the card, check it up against the enterprise systems, and then roll it into our capabilities. So right now we're utilizing the standard Armory tools for that. Okay. Always looking for other automation.
Right. Automation is really going to be key to success in the cloud. Being able to sit there and say, when this person requests a virtual machine, that it goes through some kind of workflow, where it checks to see if it meets certain parameters. If it does, automatically generate the virtual machine. Also automatically retire, sort of saying, you call it sunset, but automatically retire the virtual machine after, so many days, so many hours, weeks, months, whatever, because that'll keep your resources, freed up so that you can continue to use them, continue to expand on them, and continue to provide good service to your customers and your user base. Does anybody have any questions for these gentlemen? Yep, I'll walk around with my microphone.
For those people running their own cloud, can you speak briefly to how you address the maintenance and upkeep of the actual bare metal systems, the hypervisors? This would be Nexus in the case of OpenStack, but You can end up with a fair number of actual physical machines that are running their own OS, even if they are just running a hypervisor, a stripped-down version with a hypervisor. And you still have to account for maintenance and upkeep of those machines, access control, just things like that.
How many people in here are familiar enough with Rev to say that they've touched it, they know the basic components of it? Okay. So little background. So right now, if you have a Rev manager, if you want to make the Rev manager highly available, you put it on a HA cluster and you either run it as a service or a VM. Okay, so in that model, your underlying components, you can, fail over one side, patch, fail over the other side, and patch. Then in your Rev, your hypervisor nodes, right, as long as you have enough space to consolidate everything to one node less than what you have, you can just do a rolling upgrade all the way through. And we've pretty effectively done that for the last several iterations of Rev. I think there's some future information on what's happening with Rev that kind of streamlines that. Is that true or something you want to talk about?
And I would love to comment on it, but I can't.
Oh.
Because
Oh, right, okay. Yeah.
So for those of you who aren't familiar with Rev, it's been out for about 4 years now. Yeah. And in that short period of time, Red Hat has really caught up with a lot of VMware's capabilities. So if you're a VMware shop, definitely take a look at Rev. It may be able to, satisfy your requirements for what you're doing as a virtualization solution. And this is just me doing my best selling point right now. But yeah, definitely take a look at it. It's definitely maturing quickly.
When you talk about management, most of what you were talking about appears to be human beings allocating resources and managing them. Have you had experience with any kind of true elastic computing, auto-scaling, and/or dynamic failover?
Good question.
So with VDI components, if you have like a pool of VMs where you're farming out to a set of users, you still have to set up the user, right? The user has to exist. That's going to be a manual process. But when they log in, it spins up, next available machine in the pool. And we've done that successfully for one fairly large federal client and even over the WAN. So they can spin up both Linux VMs in a VDI capacity, which I'm going to say I understand VMware doesn't do this, but I'm not a VMware guy, so I don't know for sure. Something to look into, though. But also for the Windows instances, and they do that cross-country. And they have, better than their crummy desktop speeds in the VDI instances. So it's, in some ways, it's like they got a new machine on their desk just because they're not using the horsepower of that machine. But I would say that's the closest thing to really a hands-free, fire and forget. You set up the user, you create your pool large enough to accommodate the usage on any day. So you may have 80 users, but on any given day, 45 people in. Your pool can be 50, right? And you can accommodate that 80. So I think it covers. Is that kind of hitting the sweet spot there with the question? Okay.
You guys want to hit it, Mark, Barry?
Hi, so we've looked at some elastic capabilities in our technology. Basically, every virtual machine is associated with a template that it's created from, and we have the ability to mark that template as being scalable either elastically or horizontally. Vertically or horizontally. In the case of vertical, obviously the underlying operating system's got to be able to cope with more memory or more CPUs being added to it in flight. In cases of horizontally, what we're actually doing is watching the virtual machine, and if it looks like it's overloaded, we'll actually spin up copies of that virtual machine on other servers in order to provide additional capability. There needs to be some scripting work involved to make sure that load balancing and actually using that virtual machine is called into play, but otherwise the underlying technology handles the virtual machine provisioning side of things.
Mark?
Dovetail on it, but actually we've developed that same capability in order to do the horizontal scaling, to where we'll monitor the resources that the VM is consuming. And as we see things like traffic, memory utilization, CPU utilization start to peak, to where if somebody was surfing into through a web browser, that we could actually mimic their session, understand, or the rules would actually mimic their session, and understand, hey, this VM is reaching capacity. Your experience or page display is starting to increase, and time to return the information back to the user is spiking to the point where the website becomes mundane and nobody wants to be there. To where it would go in and dynamically take a template, spin up another VM, and continue through various sets of rules to ensure that it is truly happening because the system is being overloaded, not because one service is failing. But it would dynamically start spinning up VMs until that service level reaches an acceptable level of user experience. And then as the resources would start to drop across the VMs, it would start dropping the VMs as it went along until it reduced itself back down to one.
If any patching needs to take place while multiple copies of the same VM are online, do all the VMs get patched and updated? Does it enter into your management system so that you can control who's allowed to access it from, let's say, a console or anything?
Nope. From our perspective, the spun up machine looks like a copy of the original. So all the same ownerships. We track the administrator, the creator, business owner, technical owner, security owner, and data owner of virtual machines. And so they all have the same set of assignments. In terms of patching, it's seen as a separate machine, though, in terms of the enterprise management solution.
Okay, I think there's another question.
Well, let me add one thing to that. So in the VDI world, you create your template. You can patch your template nightly or weekly. It's easier to do that with the Linux side than the Windows side. But anyway, anytime you spin up a new machine, then it's the latest whatever template with all the patches. And since most of these things are done in a stateless way, anytime you're done, you log out, you come back in, you have to go through the sysprep procedure, which on our blades, it's about 90 seconds to bring up, and then it's a fresh instance. So if there's any patching on the Windows side that's taken place, that's happened, it's whatever the approved image is for that particular day. But like I say, it's probably once every week that they do that. With the exception of some critical patches, which may happen more often. But on the Linux side, it's much easier to maintain the image. You just apply the patches, then everybody that's getting it gets the update.
I think there's a question up here.
Hi there. My name is Lincoln Tittle. I'm with IBM. Question is, do you have any experience or use of OpenStack in things like large analytic HPC clusters and deploying those and managing any of the components within that? And if you are, do you have experience with, is it Hortonworks, or is it open source Hadoop, or is it IBM Symphony? What is it? What has your experience been?
So I'll try and take this one. Within Lockheed Martin, we certainly have HPC in use with OpenStack, but not my area. In my area, it's a lot more of a development environment. So we've done some work with Hortonworks and OpenStack and provisioning of Hadoop instances on the OpenStack infrastructure, but nothing like the kind of scale that you're talking about.
I'm wondering about how you manage your software development lifecycle with the cloud. So do you actually take your images and version your images and then push them up through? Or do you, I heard you guys talk about templates. How can you ensure that codebase X works with template Y and in rolling out patches, not breaking codebase X? To me, it would seem like it would be beneficial to actually version the image and promote the image up from like a test environment to a production environment. But then there's complexities around networking. Do you keep the same VLANs, IP tables, SE Linux, stuff like that? If you guys have any comments on that.
I think the the cleaner approach to that is perhaps OpenShift on top of either Rev or OpenStack, because that's, you know, your platform as a service piece that enables your software as a service piece. So if you're looking under the curtains, what we're talking about with the virtualization, I don't think you want to tie the two together. But this brings up a very important point in that the developers in the old days that built the very static constructs are not the developers you need for the new days, where you need to leverage the tool sets and what they do. So we see it quite regularly, introduction of a new tool that has capability. The developers aren't completely comfortable or just ignorant of some of those capabilities, and they, after training, they fall back to what skills they're more comfortable with, and it just doesn't function the way it really should function. Not as a fault of the technology, but the lack of being able to get your developers into the new mode of thinking. So if we think, the gentleman who asked about the scale on OpenStack, if you think of kind of some of the very large scale models that are out there, you know, they have their internal development shop, it's contained, it's what they need. But then they syndicate out to these large scale infrastructures, whether it's EC2 or OpenStack or Rackspace, you know, wherever you're going with it, your own OpenStack or somebody else as infrastructure. You know, by the time it gets to that, you have a static piece. You're not really doing a lot of manipulation. You've delivered the agent. It's going to spin up. It's going to create however many copies it needs to meet the need, and then your development is going to continue, you know, within your private infrastructure for the next release, and then that's going to be pushed out and syndicated. So I think there's probably a transition that needs to happen, but that transition is going to require developers to think differently about the problem from the start.
There's basically no substitute for testing, right? We have the ability, in the same way that we can associate a used one or many enclaves, we can associate a template with one or many enclaves. So it is possible to do the kind of allow this image to be used in the test, and then once we're happy with it, move it into staging and then into production. But when we're talking about moving templates around within the system, that's a task rather than a end user task.
All right, we only have time for one more question, so I'm going to let this gentleman ask. Thank you.
So it sounds like we have 3 different but similar solutions. Contribute.
So I'll talk first on the different Red Hat solutions we have. So if we talk a little bit about the satellite, we talk about more the systems management layer. The current version we have, which is satellite version 5, that is open source, and the upstream project is Spacewalk. Look at it, what's kind of satellite was originally put together. It was actually designed as a service. It wasn't really designed to be open source. So one of the different approaches that we've taken with Satellite 6 is it starts with all open source projects to begin with. So it's projects like Puppet, Foreman, Pulp, and others. So those are all upstream projects that you can contribute to today. In the case of CloudForms, CloudForms comes from a company that we acquired about a year ago called ManageIQ, and we're currently in the process of going through and open sourcing it. So we anticipate that we'll have it open source next year. It's not easy to open source a project. And one of the reasons it's not easy is there's some easy stuff to do, like go in and take out like proprietary libraries and stuff. But the harder part is you actually have to do some re-architecture to the product to make it in such a way that the community can actually consume it and actually put contributions into it, so they know maybe one piece of the software and not the entire part of the architecture. So we anticipate that CloudForms will be open sourced over the next year. And then the other one we talked about a little bit was OpenStack. And of course, OpenStack, of course, is fully open source. And we also, Red Hat has its own distribution of that with Red Hat Enterprise Linux OpenStack platform.
Yeah, let me add to that. Underneath Rev is the overt community if you're wanting to contribute directly. Underneath Satellite is Cobbler and Spacewalk. And then OpenStack's OpenStack.
And the other one I should have mentioned, we talked a little bit about OpenShift, which is our platform as a service, and that is also has an open source community, the OpenShift origin community.
All right, so I've been notified that our time is up, but I want to thank everybody for coming up here. And I appreciate the members of the panel for volunteering to do this. So everybody give them a round of applause. And then lastly, and this is probably the most important part, lunch is ready downstairs. So, all right, have a good day. Enjoy the rest of your time here.